In this video, we're going to look at geometric progressions, or GPs. A geometric progression is a series in which each term is found by multiplying the previous term by constant quantity. So I'm just going to write out a very simple one here. So if I started with 1 plus 2 plus 4 plus 8 plus 16, this would be an example of a geometric progression. So A, in this case, is 1. So A is your first term. And how you get from one term to the next is you multiply by 2. So in this case, your R, which is called the common ratio, is equal to 2. So notice if you didn't know what these were and you wanted to find out, if I took this term, the 16, and divided by the 8, that would get me the R. So 16 over 8 is equal to R. So that's what we're saying here. To find the values of R, divide any term by the previous term. So the general series looks like this. You've got A plus AR squared plus AR cubed plus AR to the 4. The general term then would be equal to this thing here. It would be equal to AR, and the R is the power of n minus 1. Okay, going to look at a couple of things here. So first thing we're going to look at is the sum of the first n terms. Now this is important. You need to know the proof of this. It could be examined, but also you need to know how to use it. So this tells you the sum of the first n terms is equal to, you've got a numerator and denominator here, so on your numerator you have a upon 1 minus r to the power of n, all divided by 1 minus r. This formula is just another way of writing exactly the same formula, but it's just sometimes a wee bit easier to use. So if r is greater than 1, it's easier to use the formula in this form. It doesn't really make a big grand lot of difference, but maybe slightly easier. Okay, we're going to look at an example now, we're going to look at the proof now of how we actually find this thing here. Okay, much like our proof for the arithmetic progression sum, we're going to write out the sum of the first n terms. We're going to write them out the long way. So the sum of the first n terms, we've got A plus AR plus, I'm just going to write the first 2, and then I'm going to leave a gap, and then I'm going to write the last 2. So I'm going to have AR to the n minus 2, and my last term would be AR to the n minus 1. I'm going to call that equation 1, and then I'm going to write that out a slightly different way as well. Now I'm not going to write that out slightly differently at all. What I'm going to do is actually multiply this thing by R and see what happens. So if you multiply the left-hand side by R, you're going to have R times S of n is equal to AR plus AR squared plus plus AR to the n minus 1 plus AR to the power of n. And that's my equation 2. Now what I'm going to do is I'm going to take my equation 2 and I'm going to subtract my equation 1. So I'm going to do that on both sides. So on my left-hand side, I will have R Sn minus Sn. So that's what I'll just write that down. That's R Sn minus Sn. On the right-hand side, you're going to have this term, notice, will be cancelled out when you subtract this term. This term would be cancelled out when you subtract what would have been here, and so on. And this term would have been cancelled out when you subtract this, and so on. So what you're going to be left with is this very last term. You're going to be left with this term, and also minus the a. So if you subtract, you're going to be left with a r to the n minus a. Okay, what we're looking to find, always think, what are we actually trying to find here? We're trying to find the formula for s of n. So we want to isolate it, get it on its own. So I'm going to take it outside a bracket on the left-hand side, leaving me r minus 1 is equal to, and I'll take an a outside the bracket here, leave me r to the power of n minus 1. And then the last thing I'll do is just come across here, and then I'll just divide across by your r minus 1. So a upon r minus r to the power of n minus 1, all divided by r minus 1. And that's your formula. Okay, and just how you get to the other formula, you could just say, if you multiply the top and the bottom by minus 1 over minus 1, you would just get S of n is equal to a times 1 minus r to the power of n all over 1 minus r. And so multiplying top and bottom by minus 1 over minus 1. sum bottom by minus 1, I should say. That's the same as multiplying by minus 1 over minus 1, and that would just be equal to 1. So it changes how the thing looks, but it doesn't change its worth, so they're definitely just the same thing. This example says find U5 and S5 of the GP in which A is equal to 27 and R is equal to 2/3. So U5 first of all. UN, we'll write down our formula. First of all, it's A times R to the power of n minus 1. So U5 in this case is equal to, and my A is equal to 27. My R is 2/3. And my n minus 1 then, it was 5 minus 1 is going to be 4. Fire that into your calculator and see what you get. And I got U5 is equal to 16 over 3. If you don't like that, you can of course write that as 5 1/3, but 16 over 3 would be fine for me. Next thing, we want to find our S of n, S of 5 I should say. So S of n, remember, was equal to A over 1 minus R to the power of n all over 1 minus R. So S of 5 in this case is going to be equal to 27 upon 1 minus 2/3 to the power of 5. And then that was all divided by 1 minus R. I'll just write that in as 1 minus 2/3. And again, fire that into your calculator and see what you get. So S of 5 worked out to be 65. This example says a GP has a first term of 27 and a common ratio of 4 over 3. Find the least number of terms that the series can have if its sum exceeds 550. Okay, right. A lot going on here, so let's just start writing down a few things. Make it a wee bit easier for us. So A is equal to 27. My R is equal to 4 over 3. My S of n has to be greater than 550. That is the goal of this. We want S of n to be greater than 550. First of all, I'm just going to write down what my S of n is equal to. It is A upon 1 minus R to the power of n, all divided by 1 minus R. So in this case, S of n is equal to 27 times 1 minus 4 over 3 to the power of n, and that's all divided by 1 minus R. So that's going to be 1 minus 4 over 3. You can see here, if we look at this, I'm going to have a negative on the bottom line. It may have been nicer for me to use the other formula here, but it doesn't really matter. We'll just work on with this just to show you can use either. So if I tidy it up a wee bit, I'm going to have S of n is equal to 27 upon 1 minus 4 over 3 to the power of n. And the bottom line is going to be minus 1/3. Okay, I think I will sort that out now. I will divide through by the minus 1/3. So I'll have S of n is equal to, that's going to be minus 81 times 1 minus 4 over 3 to the power of n. And I'll just multiply in with that. That's going to be, that's going to be 81 upon 4 over 3 to the power of n, then minus 81. So just multiply it in, tidy it up a wee bit as well. Okay, right. Put the brakes on and have a look at the question. It says, find the least number of terms the series can have if its sum exceeds 550. We've now got its sum. We want this thing to exceed 550. So that means 81 upon 4 over 3 to the power of n minus 81 has to be greater than 550. So that's what we're looking for. So again, that's going to be 81 upon 4 over 3 to the power of n is going to be greater than, it's going to be 631. And we'll just come over here, divide across. You got your 4 over 3 to the power of n is going to be greater than 631 over 81. And then what we're going to do, have to do here is take logs. So on my left, take logs. Left hand side is going to be n log of 4 over 3 is greater than log of 631 over 81. And that means your n has to be greater than, and it's going to be log of 631 over 81, and then divided by log of 4 over 3. Do that in your calculator and just write it as a decimal. I got n is greater than 7.135 ... Therefore my answer has to be the least number, so it's going to be m is equal to 8. Last example says the second term of a GP is 8 over 9 and the sixth term is 9 over 2. Find the first term and the common ratio. Okay, no idea again. So we'll just say what we have. It says U2 is equal to 8 over 9, and then we'll just play around with our formula. So that means if that's U2, my second term is equal to 8 over 9. That means AR to the power of 1, so AR just is equal to 8 over 9. And I'll call that equation 1. It also tells me U6 is equal to 9 over 2. So that means AR to the power of 5 is equal to 9 over 2. And that's going to be my equation 2. Okay, so lots of different ways of doing this. You could substitute, you know that AR is equal to 8 over 9. So you could say 8 over 9 times R to the power of 4 is equal to 9 over 2. Lots of different ways you do this. You could rearrange and make R the subject in the first equation, then substitute it into the second equation, or the other way around, make A the subject. But what I'm going to do here is I'm just going to do equation 2 divided by my equation 1. So we'll do our left-hand side. So your left-hand side, you'll have AR to the power of 5 divided by AR, and that's going to be equal to, and you're just going to have then 9 over 2 divided by 8 over 9. So again, I'll come up here and finish this off. Left hand side, you had AR to the power 5 divided by AR, so the A's cancel. Then R to the power 5, pardon me, R to the power 5 divided by R is just going to be R to the power 4. And the right hand side of that was 9 over 2 divided by 8 over 9. And if you do that out, you're just going to get 81 over 16. Okay, R to the power 4 is equal to 81 over 16. That means R will be equal to the fourth root of 81 over 16. Now, hopefully you can spot what these would be. The fourth root of the numerator, fourth root of 81. 3 multiplies by itself 4 times to give you 81, so the fourth root of 81 is 3. Likewise, 2 multiplies by itself 4 times to give you 16, so 2 times 2 times 2 times 2 gives you 16, so the fourth root of 16 is 2, so your R is equal to 3 over 2, or 1.5. Last thing for us to do is find A, so we'll just say in equation 1, we now know my R is 1.5, I will not write it as 1.5, I'll write it as 3 over 2. Is equal to 8 over 9. That means A is equal to 8 over 9 divided by 3 over 2. So we'll just do this out the long way, showing our working out here just for the sake of it. So you have 8 over 9, and dividing by fraction, you change the dividing fraction, flip it upside down and change the divide sign to multiply. So that's what we have, and then we can do a wee bit of cancelling down. No, we cannot do any cancelling down. We can just multiply along the top and get 16. We multiply along the bottom and get 27, and that's it. Okay, tidy it up for the examiner. Your answer, A is equal to 16 over 27, and your R is equal to 1.5, and I will just leave it as 1.5. Okay folks, you're now ready to do the sequence and series questions, exercise 4.